Welcome to this deep dive. We're tackling a classic today,
Yeah.
one that really made people think differently about science.
Yeah, Thomas Kuhn's The Structure of Scientific Revolutions.
Right, from 1962, but still gets debated like crazy.
Oh, absolutely. It's one of those books that, well, it kind of sparked its own revolution in how we see science.
So get ready, folks. We're going to explore how those big scientific ideas, those truths we take for granted, well, they can change in some pretty wild ways.
Yeah, Kuhn called those moments paradigm shifts.
Okay, gotta ask before we get too deep, what exactly is a paradigm?
Think of it like the framework you use to make sense of the world. A set of glasses scientists wear. It shapes how they see things, what they even consider a good question to ask, what methods they use.
So what we think is a scientific fact today could be totally wrong tomorrow. That's a little unsettling, to be honest.
It can feel that way, but that's what Kuhn was saying. Science isn't just this straight line to the right answer. It goes through these huge GE shifts, these moments where the old way of seeing things just crumbles and a new one pops up.
Okay, so give some examples. Kuhn talks about these anomalies, those bits of data that just don't fit the neat picture, right?
Exactly, like puzzle pieces that just won't go in. He uses Ptolemy's model of the universe. Worked fine for centuries. But there were always these little problems with how the planets moved. Astronomers kept trying to make it work.
Like jamming a square peg in a round hole.
Aha, exactly. They kept adding complexity to the model more and more.
So it all became too much.
And then Copernicus comes along with this radical idea. The sun, not the Earth, is at the center.
Boom, paradigm shift. But did everyone just suddenly agree? End of story.
Oh, if only it were that simple. Kuhn argued that these different paradigms, they're what he called incommensurable. So different, you can barely even compare them.
Incommensurable. Sounds intense.
It is. Like, imagine those optical illusions. You see a duck or a rabbit, never both at the same time.
Yeah, I get that.
Your perception changes, but the image is the same.
Okay, I kind of see what you mean. But wouldn't scientists at least agree on the basic facts?
Well, that's just it. Even what we consider a fact can change depending on which paradigm you're in. The way you look at data, the very questions you ask, it's all influenced by that framework.
It's like they're speaking different languages almost.
Exactly. Same words, different meanings. Imagine trying to discuss physics with someone still using Aristotle's ideas. Good luck finding common ground.
My brain's starting to hurt a little. So if everyone's in their own little world, how do these revolutions even happen? It can't just be logic and evidence, right?
That's one of Kuhn's most fascinating points. It's more like, and this might sound odd, a conversion experience.
Oh, look, conversion. Like a religious thing?
Not quite, but similar in how people's thinking changes. Kuhn said embracing a new paradigm, it's like seeing with new eyes, a total shift in your perspective, even if the proof isn't all there yet.
So you're saying, okay, this seems to work even if I don't totally get it, I'm going with it.
Precisely. And often it's the younger scientists, newer to the field, they're the ones who make that leap.
Because they've got less to lose, less invested in the old way.
Maybe, but also because they're not as stuck in their ways, more open to seeing things differently.
Like, hey, this solves problems the old way couldn't. Let's explore.
Right. It's not always about being right. It's about what's more useful for understanding the world.
Okay, I'm following you. But what happens next? How does a new paradigm actually win over the whole scientific community? That's got to be more than just a popularity contest, right?
Think so, but, well, we'll get into that in the next part of our deep dive.
Back again for more Kuhn. We're really getting into the nitty-gritty of how those big scientific revolutions, those paradigm shifts, actually go down.
Yeah, and it's not always pretty, that's for sure. We were saying last time, it's not like everyone just snaps their fingers and adopts the shiny new idea.
Right, it's got to be way more complicated than that. So how do scientists even start to see that maybe, just maybe, their old way of thinking is, well, wrong?
That's where those anomalies we talked about come in. Remember, the stuff that just doesn't fit the existing paradigm, but it's tricky because scientists don't always spot them right away.
I guess if you've been working a certain way your whole career, you'd try to make those weird results fit somehow.
Exactly. Scientists are trained to solve puzzles, but within the rules they already know. So their first instinct is to tweak the existing theory, not throw the whole thing out.
Like, must be something wrong with my experiment, not the fundamental laws of physics.
Pretty much. Kuhn actually compared it to those psychology experiments where people miss changes in images because they're not expecting them.
So it's not just about being smart. It's about being open to being wrong.
Totally. And those anomalies, they start to pile up like little cracks in the foundation. Scientists start getting this feeling like something's off, but they can't quite put their finger on it.
It's like a puzzle where more and more pieces just refuse to fit no matter how hard you try.
And that unease, that can build into a full-blown crisis. The old paradigm, the one that seemed so solid, starts to feel, well, shaky.
Like the whole scientific community is having an existential crisis.
Kinda, yeah. And that's when things get really interesting. That crisis opens up the possibility for new ideas, new ways of seeing the world.
Okay, so someone comes up with a new paradigm that seems to fix those problems, explains the anomalies and all that. But how does that new idea actually win? It's got to be more than just convincing people, right?
You'd think so, wouldn't you? But Kuhn argued that it's not just about cold, hard logic. He used this phrase, and I know it sounds weird. He said it's like a conversion experience.
Wait, hold on. Didn't we touch on this before? Are we saying science is like religion now?
Not exactly, but there are parallels in how people's thinking shifts. Kuhn argued that embracing a new paradigm, it's like you suddenly see the world with brand new eyes. It's that deep of a change.
So it's not just learning new facts, it's adopting a whole new way of seeing everything.
You got it. And just like with any big change, there's going to be resistance.
The scientists who are really attached to the old way of doing things.
Exactly. They built their careers on it, spent years, maybe decades working within that framework. Letting go is tough.
It's like having your whole world turned upside down. Suddenly, everything you thought you knew is up for debate.
That's a good way to put it. And those scientists, they might raise some good points. They'll point out flaws in the new paradigm, maybe even try to disprove it with experiments.
So there's pushback. It's not just everyone rolling over and saying, oh, okay, new science time.
Definitely not. These paradigm shifts, they can be long and messy, lots of back and forth debates and arguments before the new one really takes over.
Like a battle of ideas, playing out over years, even decades.
Exactly. And one thing Kuhn pointed out was that it's often the younger scientists who champion the new paradigm.
Because you haven't spent their whole lives invested in the old one.
That's part of it, but also they're just more open to new ideas, more willing to take risks, you know?
Makes sense. They're less set in their ways.
Right. And if that new paradigm, if it really works, if it explains things better, makes better predictions, then it slowly starts to win people over.
Okay, but better how? Like, how do you prove one paradigm is superior? It's not like there's a scoreboard.
That's the thing. It's not always cut and dry. Sometimes the new paradigm is just more elegant, simpler. Sometimes it makes more accurate predictions, or it opens up new areas of research, new questions to ask.
So it's not just about being right. It's about being more useful.
You got it. And as more and more scientists buy in that new paradigm, it starts to change the whole field.
Okay, I gotta ask, what happens to the old paradigm then? It fades away.
That's the million-dollar question. And that's what we'll get into in the final part of our deep dive.
All right, final part of our Kuhn deep dive. We've been through a lot, those huge shifts in science, paradigm shifts.
Yeah, those moments when everything changes how scientists see the world.
Right, and how messy those shifts can be.
Like we said, not everyone's happy to throw out the old ideas, especially if they built their whole career on them.
And we left off asking, what happens to the old paradigm once the new one shows up? Does it just kind of vanish?
Yeah, that's a good question. Because remember, those paradigms are so different, so incommensurable.
Right, Kuhn's fancy word for basically impossible to compare.
Yeah. So how do scientists even talk to each other during this transition? That's what Kuhn was getting at. It's tough.
Yeah, if you're used to thinking one way for so long, even understanding the new way is a challenge.
Exactly. So how does the new one actually take over completely? Do those old school scientists just retire?
That's what I was thinking.
It happens sometimes, sure. But Kuhn said it's more of a gradual shift in the whole community. More and more scientists adopt the new paradigm. It becomes the default.
So it's like a snowball effect?
Yeah, the more people buy in, the more momentum it gets. And as that happens, the whole field changes. Textbooks get rewritten, research projects focus on the new stuff. Young scientists are taught the new way.
And that old paradigm, it just becomes history.
Pretty much. Kuhn said once the new paradigm's in charge, the old one's almost invisible, like it never even existed. Future scientists might read about it, but they won't get why anyone believed it.
That is wild to think about. So are all our scientific theories just temporary then? Could everything we know be overturned someday?
Well, Kuhn would say it's not if, but when. He argued that science isn't about reaching some final truth. It's a process of constant revolution, these paradigm shifts that change our understanding.
Okay, so it's not about getting to the end. It's about the journey, the constant exploring.
Exactly. And each shift, each revolution, it opens up new possibilities, new questions to ask, new mysteries to solve.
Hmm. That's actually kind of optimistic. It means we'll always be learning, always pushing the
It's the
boundary.
beauty of science. It's
Okay.
this never-ending quest for knowledge, right? And Kuhn, he reminded us, it's not always going to be neat and tidy. There's going to be surprises, debates, even those
Yeah,
revolutions.
after all this, I'm less sure about what truth even is, but way more excited about what we might discover next. Who knows what mind-blowing paradigms are waiting out there?
And maybe some of our listeners, they'll be the ones to discover them.
That's a great thought. Thanks for joining us on this Kuhn deep dive. Keep questioning, keep exploring, and who knows, maybe you will be the next revolutionary scientist.